that's fine.
Good enough.
That'll do.
Then E. And F is over. Hold up, what? It's over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then up. 1, 2, 3, 6. 1, 2, 3, 4, 5.
Oh, we'll just pretend that.
6.
Yeah. And if you want to circle, you could bring it down one row, unless that doesn't matter.
How do I do that? This
So
one?
circle the whole graph, yeah. And then
Get
just,
F in
you
there
can
too.
get F in there, and then just bring it down 1 or 2 is fine, yeah.
Cool.
Now fix your F.
Yeah.
You F'd up your F.
Okay. Boom. F. Oh, now it's still thrown off.
Yeah, it was just barely below where it's supposed to be.
Okay, so
It was 5.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6.
Cool. All right, and now draw your line, which takes some dexterity. Nice.
Nice. Cool. Arrows.
We'll call that top
No
of
idea.
arrow, I guess.
Okay. Perfect.
All right, there you go.
All right, so we'll go from right to left, I guess. So we'll go over 1 and up 2. So over 1, up 2.
You did just say right to left. I think you meant
Or left to right.
I think
yeah,
you meant
my
left
bad.
to right. And by the visual, that makes sense, right? Up
Yeah.
1 over 2. Oh wait, up 1 over 2. Wait, up 1 over 2. Up 1 over 2.
Wait.
I'm veering off track here. It's rise over run. So how much do you go up?
Oh,
Every time you go
okay,
over
yeah,
1.
Yeah, you go. I see. So up 2, over 1.
Cool.
Cool.
Yeah, change in y, change in your up and downness,
Or
divided by the change in x, which we try to just say, keep it 1, makes life easy. Okay, up 2 over 1. Up 2 over 1. In fact, grab that little laser pointer and track it. Up 2 over 1.
2 over 1.
Up 2 over 1. Up 2 over 1. Okay, and just for the sake of it, go ahead and do the same type of calculation, but use the points E and F. So how much do you
Okay.
go up and how much do you
You
go
go
over?
1, 2, 3, 4, 5, 6. 1, 2, 3. So up 6. Oh, whoops. Up 6 over 3.
Yep.
Which makes sense because that's double that.
Exactly
6
right.
is double 3, 2 is double 1.
Exactly right. And if you simplified this, what is 2 divided by 1?
2 divided by 1, 2.
2. And what is 6 divided by 3?
6, 3,
How many times does 3 go into 6?
2,
2. How many times does 1 go into 2?
2.
2, right? And this could also be up 8 over 4. You'd be right on the line. Up 100 over 50.
Yeah.
You'd be right on the line. Up 10 million over 5 million. That would end up, like literally that point would get perfectly intersected eventually.
Yeah.
As long as the y value is twice as big as the x value.
So that's the next episode. Going to 50
Yeah,
million.
yeah, we're just going to zoom this thing out really, really small. Yeah, I mean, slope is not too tricky, but it's actually extremely useful
Yeah.
for determining things like speed, like the amount of money you expect to make monthly and such. Because, you could have a graph that's money by time. And if you know how much money you're making per time, you know your hourly wage or your salary,
Yeah, exactly.
speed of cars, and then slope gets really fun when your graph, instead of looking like this, starts to look like this.
Yeah.
And now you're finding slopes at individual points, knowing that the slope at every point is going to be a little different than its neighboring spots. That's calculus.
Okay.
Anyway, we don't
Cool.
have to do that. But it does expand from just literally doing rise over run every time. Because I know it gets boring. But anyway, let's keep with the boring.